Okay, we're now ready for E exam review, exam for exam 2 review E, which is the fifth one. Here comes the heading, the usual spring 21 exam 2 review, and this is E. We are up to problem number 14. Alex will be very clear about showing you how cards work. I'm going to give you most of it as follows. There's two types of reds. Let me do most of what Alex will show you. You've probably seen this on the homework. Problems like this. So there's two types of red, two types of blacks. So the red is there's hearts and there's diamonds. Black, there is spades and there is clubs. And then you can have an ace. There's 13 types of cards. In each house, they're called houses, I believe. And each house, there's 13 cards. There's an ace, there's a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. That is the cards. So there's 13 in each, right? There's a 13 of hearts, 13 of diamonds, 13 of spades, 13 of clubs. Total of 13 times 4 is 52 cards. Okay, so there's 52 cards in all. Now, you pick, obviously one card is picked at random. One card picked at random. And here comes the questions. There are 3 of them. First of all, A, what is the probability of getting an 8? Answer. The answer is, how many 8s are there? There's going to be 4 of them. Hearts, diamonds, spades, clubs. So the answer to that is pretty straightforward. It is 4. I don't know what I said. I hope I said it right. But there's 4 ways of getting an 8, right? Hearts, diamonds, spades, clubs is 4 8s. So that's 4 out of the 52 cards. But Alex does not want 4 out of 52. Alex wants you to reduce the fraction to the lowest form, and therefore you answer 1 out of 13 if they're willing to take a fraction. If they want a decimal, you would have to divide 13 into 1. I don't think they want a decimal, but just in case they do, that's what I mentioned. It's worth mentioning, I guess. Now, what about the probability of getting a heart? All right, well, there's the denominator is 52. The denominator is 52. The sample space is 52 because there's 52 cards, and you're picking one card only from the deck of 52. So there was 4 8s, but now how many hearts are there? There are 13. There are 13 hearts. You can count them. There are 13 hearts in all. What is that? Reduced, that is 1 out of 4, and that is the expectation of what you're supposed to give as the answer to the problem. All right, let me move this up slightly. Try to keep that thing in view still. No, I want this down. I don't want it too far up. I want it like that. Okay, so you can still see the stuff about the cards. Okay, now here comes C. What is the probability of getting an 8 or an H? Now, here's where you got to be careful. The formula for probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersect B in case they have something in common, in case they're not mutually exclusive. So you'd be tempted to say, you know what the probability of 8 or H is? Well, I just figured out 8 is 1 over 13. I figured out H is 1 over 4, so let's just add them up. You can't do that. Let me show you why. We've had this during the semester. Let me show you why. What's 8? 4 out of 52. Let's keep the original denominator. When you're working something like this out, go back to the original denominator. Don't work with the reducing stuff. 4 out of 52. Okay. Plus how many? So that's P of A. We'll call this A. We'll call this B. P of A is going to be 4 out of 52. What is P of B? If we call H B, what is P of B? It is 13 out of 52. Now, you have to subtract minus P intersect B. Is there something in common with the hearts and the 8? The answer is that, can you have something that is both an 8 and a heart? Of course you can. The hearts has an 8 in it. So you have to subtract minus how many of those, how many cards are both a heart and an 8? Only 1 out of 52, but you got to subtract that out. So therefore you have 17 minus 1, which is 16 over 52, and that's what's going to lead us to the final answer as soon as we reduce it. As soon as we reduce it, we get 4 over 13, and this is the final answer. Because if not, we counted the hearts, the 8 of hearts twice. The 8 of hearts is in here, and the 8 of hearts is also in here. You count it twice. You got to subtract it out once to get the proper answer. Okay, that's problem number 14. We are out of space. Let's go to a new page for problem number 15. Here we go. Problem number 15 looks like this. It's not terribly long. It's not terribly short either. Problem number 15. Coin is tossed. One coin is tossed, or let me put the 1 here. Tossed 3 times. Okay. Now, Alex does as follows. They are going to set up with there's a set up a column over here called outcomes, and they're going to be nice enough to show us the entire sample space of throwing a coin 3 times. This is what Alex does. I assume you probably see this on homework. Well, they have their own way of doing it. I would personally put HTH first, but that's what they did, so I'm going to do what they did. Then TTT, then HHH, 3 H's, then HTT, then TTH, TTH, then THT, THT, then THH, THH, and I got room for the last one, which is HHT. So I'm going to try to subtly put this in, HHT. Okay, and then they give you boxes. They give you boxes. Let me show you what the boxes look like. Well, you can sort of imagine what the boxes look like, but let's do it anyway. And they ask you, 3 questions. 3 questions over here. So they always make these nice, neat tables, which is good. It makes it pretty clear what they want. Event A. What's event A? Event A is exactly 1 heads. Exactly 1 H. 1 heads. So this is what you do. Where do you have exactly 1 H? Right over here, HTT. You check that box. And then TTH, you check that box, exactly 1 heads. And that's it. The rest have either 2 heads or 3 heads or no heads. But the one's exactly 1 is that. So that's the outcomes you do for event A. Okay, event B, I need more space. Event B, you'll get boxes too, but I'm tired of the boxes. It's too much for me to write because it just wastes a lot of time on the video. So event B is no H, no heads on first 2 tosses. Okay, so we got to check out the outcomes where you have no heads on the first 2 tosses. Well, you have heads on the first 2 tosses. This is good for no heads on the 2 tosses, right? So I'm writing the checks next to on this row. There's heads in these first 2 tosses. There's a head in these first 2 tosses. There's no heads in this first 2 tosses. There is here, and there is here. So forget it. There's only only two outcomes that fit the bill. Now, the last thing is the probability. So I'm going to put the probability over here. They'll have it over here on the right-hand side. I'm running out of room. I am going to have to put the probability over here. So what's the probability of this one? The probability of this one is 2 out of 8, right? 2 out of 8, which is 1/4. So the probability for this is 1/4. Putting the probability on the wrong side, but I have no room. So I have no choice. What's the probability of this one? It's also going to be, what does it say? Exactly 1H? I missed it. I blew it. There's another one that's exactly 1H. Sorry about that. Someone must have caught me there. Exactly 1H is not 1/4. It's 3 out of 8. Sorry about that in my haste here. Oh, that's what I'll blame it on. It's 3 out of 8. This one I got this one right. This is 1/4. Now comes event C. Event C, which is heads on each of first two tosses. Heads on each of first two tosses. Okay, this is the last one, so I have some room to do it in. Now, what is this? Heads on first two tosses? Not there. Not here. Yes, here. Not here. Not here. Not here. Not here. But yes, here. First two tosses. So this is good. And therefore, it's 2 out of 8. And the answer is 1/4. The probability is 1/4. So let me go over this. I made a mistake here. Not a big deal. I think you'll agree. Exactly 1H. Well, there's exactly 1H here. There's exactly 1H here. And somehow I missed this one. There's exactly 1H here. So it's 3 out of 8. And that's the probability over here. This is supposed to say, I'll just write it right next door over here, 3 out of 8. Okay, because this is a mess. There we go. That is it for problem number 15. It's over and it's done. For problem number 16, no, it's one of those big, lots of stuff, lots of writing. That's the problem here. So much writing that it's not worth it. Let's go to a new piece of paper.